Okay, assalamu alaikum everyone. Today we are going to give a tutorial about chapter 7 and exactly the psychometric chart. Okay, you asked for specifically to how to calculate the values on the psychometric chart. Okay, just let me recap or introduce again the psychometric chart. The psychometric chart, like this one here, they are taken at constant pressure, and they are used to calculate the following properties: specific humidity, relative humidity, and the wet bulb temperature, dew point, dry bulb temperature. And in our psychometric chart, we are also able to find the enthalpy of the air. Okay. Here also we can find there's two other properties that we can find, not directly from the psychometric chart, but after getting the psychometric chart, we can find the following two properties: the density of the vapor, which can be calculated from the specific humidity divided by the volume. Also, yeah, I forgot to mention that the other property that we can calculate is the volume from the psychometric chart, and we can find the pressure of the vapor from the relative humidity and the P of the PG. Okay, so we'll take the following example. We have, in these type of questions, you'll be given two properties, and you'll ask to calculate the other 5 or 6 properties. So here in this example, the dry bulb temperature is 40 degrees Celsius and the relative humidity is 30. So to solve these kind of questions, we have what to do first is to decide where is our point, like to determine our point specifically. So here we can see that it is written that here is the dry bulb temperature. So along this axis, the dry bulb temperature is changing from 0 to 50. And since we are dealing with air and ACs, like these types of charts are used for HVAC and ACs, we don't need like temperatures below 0 or 50 because we will not be using them. So here, first our point will be here in this line, right in this line. Okay, I'll try to draw it as straight as I can. It is not very straight, but you have to use the ruler here because now I'm on the computer. I can't use one. But first, you determine that your point will lie here at the 40 degree Celsius. And then from the other property, which is the relative humidity, which can be read from these lines, this 1, 2, 3, 4, that vary from 0 to 100% relative humidity, this which is represented by the saturation line. So our point will lie in the intersection between the relative humidity of the 30 here and the 40 degrees C. So if we zoom them, here our point will be 40, here exactly, here at this point. Okay, now till here, till deciding the point, is there any problem? Do you have any question till this point? How to find the point that we'll calculate the other properties from? Okay, clear. Okay, so now after deciding this point, we can see here that it is written inside the graph itself where to find the other properties. Okay, this is the relative humidity, we already used it. Here the wet bulb temperature, you can see that these dotted lines, this one and this one, are used for the wet bulb temperature. And to see how they varies between line to line, you can see that here in this line it is 30 and here it is 25, and there's 1, 2, 3, 4 in between. So each line represents 1 degree Celsius difference. So here, to start with the wet bulb, if we follow this line, because it is going from our point here, the line is a little bit not straight, but if you use a ruler, you'll get a straight line, and you can see it is directly at the 25. So the first property that we calculate is the wet bulb temperature, which is equal to 25 degree Celsius, and we got that from the dashed line. Now the next property that we can get is the relative humidity, the humidity ratio. And the humidity ratio, to get that, we will go here to this line. We'll go here horizontally to this line here and see where we will stop. But here we have to notice one thing, that it is written that our relative humidity, the one that we will get, it will be grams of moisture per kilogram. So the unit of these is gram per kilogram. And if we want to convert it to kilogram per kilogram, we just have to divide the result that we got by 1000. Okay, so to do so, okay, can use the ruler. We already located the point here in the intersection of the two properties that we were given. So we will go to the left with a straight line. It's not exactly straight, okay, but drawing a straight line, you can get it. And here we can see that it is at 14. Our relative humidity, the W, is at 14, and this 14 represents gram of H2O over kilogram of air, dry air. Okay, so till now we found the wet bulb temperature from these dotted lines, and we found the humidity ratio, the W, from drawing a horizontal line till it intersects here with these values. Then the third property that we will calculate is the dew point. Okay, so to do the dew point, we'll draw the same horizontal line, but instead going to the right, we'll go to the left and see where it will intersect with these values that are drawn. Okay, so doing that, we'll go here to the end. Okay, and how to read this value when we stop here on this line? We can see that they vary from 15 to 20 to 25. So we have to divide this area here in between to 5 equal portions, or a quicker way is to draw a line directly down and see where it will intersect this line. So you can either read it directly from here, or you can go draw another line and go down and draw here. And here we can see that the dew point, our dew point, is at 90 degrees C. Now what does the dew point mean? Here in this dew point, in this line, the saturation temperature, it means that our air holds the 100% of water, so it cannot carry any more water. So if we go beyond this temperature, like here we found that it's 19, but if we have object at 15, here it is below the dew point, so the water particles will start condense, because it's already here at 19, the air is holding the maximum amount of moisture that it's carrying, and going far beyond that, it will result in condensing the water particles around our object. So this is basically the dew point. Okay, now the dew point is at 100 degrees C. Okay, this is the third property that we got after the wet bulb and the humidity ratio, dew point. Now we can find one more thing, the last property, which is the enthalpy. And enthalpy is H, which we can use to calculate the energy when doing the cooling or heating by subtracting the enthalpy after doing the energy balance between the 2 points. Okay, but in this case we'll find the enthalpy at just this point here. To do so, we can see that these lines here, this one, this and this one, the thick black lines, they represent the enthalpy. So here our point, it will be between this line here and this one here. Okay, between these two lines. There's no lines in between, just these two. This one represents the 80. Here, if we extend it furthermore, the enthalpy will be 80 kilojoule unit per kilogram. And here it will be 70. So you can do either one of two, either to approximate the distance. Here this is the total distance here between the two, and your point is here. So we can say that it is more than 75 because it is a little bit more than the half. So we can say that H is like around 77. Or you can do another thing, which is drawing a line which is parallel to these two and connecting it to the top. So either ways will be fine. You can get it either by using this method or drawing a parallel line to these two and connecting it to the top here where the enthalpy are written. Okay, now this is kilojoule per kilogram. And here at the end there's still one more property, which is the volume per kilogram. So it is small v, specific volume. Okay, and the lines, again here, these lines that are drawn like that are for the volume. And the variation between each line and line is 1 unit, you can say, because here it's 0.92, so this line will be 0.93, this is 0.94, and then 91, 90, 89, 88. Now again, we can do the same thing by creating here. This is the first one and the second one that our point lies in between. So it is between the 90 and 91, and here we can say that it is much closer to the 91 than the 90. So the volume will be 0.90, you can say 8 or 7, depending on your approximations. And here the unit will be meter per kilogram. Okay, so here we got the wet bulb temperature, relative humidity, dew point, enthalpy, and the specific volume. All these properties we got them from the chart just by knowing that, but just by knowing two other properties and drawing the intersection as we did at the beginning, then everything will be clear. Okay. This is it for finding the properties from the chart. Do you have any question regarding any of the points? Clear. Okay, good. Clear. Okay. Okay, that's fine. Okay, and just one more thing. We can also be asked about like extras to find after, like we can ask to find the density, for example, or the pressure of the vapor. And how to do so, as I mentioned earlier, here we can implement these two equations. in and substitute with the properties that we found to calculate. So we know that the density is mass over volume from the basic principles. And here the humidity ratio, it is basically representing the mass of H2O over the mass of air. And the specific volume that we found is meter cube per kilogram air. So cancelling out these two, we will find the density of the wet air, which can be calculated from the relative humidity over the V. So here in this question, if you see that our W is, we found it to be 14 gram or 0.014 kilogram H2O over kilogram air. This will be divided by the specific volume, the 0.90. Sorry for the bad handwriting. Meter cube per kilogram. So cancelling out kilogram of air with kilogram of air, dividing these two, will get the density of the vapor, the H2O. And we can do the same for finding the vapor of the pressure vapor by using the relative humidity from the beginning of the chapter. The laws from the beginning of the chapter, the relative humidity is PV over PG. You can find PG from the tables, and the relative humidity in this question, it was given to be 30. So 0.3 equal PV over PG at the given pressure that the psychometric chart operate with, and it will be usually the atmospheric pressure, because as I mentioned earlier, these are used in HVAC and AC, and ACs usually operate in the atmospheric pressure, but I think it will be mentioned in the question if anything different. So you find PG at the atmospheric pressure or the pressure given, and multiplied by the relative humidity, you will get the vapor pressure. Okay, that's it for psychometric chart. I think we covered everything. For that, yeah, that was everything I want to say. Does anybody have any question? So just to recap, the last formula. Okay, which one, the density or for the pressure, the vapor? Okay. Okay, at the beginning here, the density of anything, it is mass over volume. This is the basic definition for the density. And here, if we want to find the density of the vapor, we can, using the properties that we have here two things that we can determine with. First is the humidity ratio, W, because we know W is kilogram H2O over kilogram air, because here from the definition, the humidity ratio is just humidity ratio is the amount, the mass of the vapor divided by 1 kilogram of air. So this divided by the specific volume of our vapor, which can be here found from here, the specific volume, cubic meter per kilogram. So here the unit will be meter cube per kilogram air. So cancelling out kilogram air, we will get kilogram H2O divided by meter cube, and dividing the relative humidity by the specific volume, we can get the density. Now this is for the density. Is it clear? Okay, good. Now for the vapor, from the beginning of your chapter 7, the relative humidity phi can be divided from PV divided by PG at the operating pressure. Okay, the relative humidity, it is either given or we can find it directly here on this lines, the relative humidity, by doing the intersection. Okay, then after deciding the relative humidity, the PG at the operating pressure, it will usually be the atmospheric pressure. We go to the tables, the thermodynamic tables, and find PG. And the pressure, as I said, it will either be the atmospheric or it will be given if it's something not the atmospheric. Then, knowing these two numbers, we can just rearrange the equation. PV will equal to the relative humidity multiplied by PG at the pressure. And then you'll get the pressure vapor. Is it clear now? Okay, good. Okay, any more questions? If no more questions, I'll stop the recording here. Thank you for attending, and if you have any question, you can contact me. You're welcome. Stop it here.